Hello, we are Katia, Salma, Daniela, Angel, and Salma. This is our tutorial, hydrocarbon, how to name it and draw it. We hope you like it.
Wow! Here's the objectives. The main objective of this activity is to develop a tutorial on how to write a name for different hydrocarbon types by UPath, as well as drawing the structural formula, giving examples, and putting into practice or learning a prior job state for it. But what is a UPath and what does it do? The UPath is the International Union of Pure and Applied Chemistry. It is an international scientific organization, not affiliated with any government. The UPath strives to advance chemistry in part by setting global standards for name assignments and units. Its aim combines oversee the union's work in chemistry. The UPath was formed in 1918 by scientists and academicians who recognized a need for standardization in chemistry. It will be important to familiarize yourself with this name, as they will be the basis of naming many other organic molecules throughout your course of study.
What are hydrocarbons? Hydrocarbons are organic chemical compounds that consist entirely of carbon and nitrogen and range from simple molecules such as methane to polymers such as polystyrene, which consists of thousands of atoms. These are examples of hydrocarbons. The hydrocarbons have classification. Their first is alkanes. Contains only carbon. Carbon single bonds are saturated. General formula is this. Next are alkynes or olefins. Contain a single carbon-carbon double bond. General formula is this. Alkynes contain a single carbon-carbon triple bond. General formula is this. This is a table that contains the other example and the general formula.
Alkane. Hydrocarbon contains only single bonds between atoms. The general formula is CnH2n plus 2. It's a saturated hydrocarbon. Call it saturated because each carbon is bonded to 4 or other atoms. These are examples of alkanes. This is our ethane and propane. The UPath rules to name alkanes. Step 1. Count the number of carbon atoms in the longest continuous chain. Step 2. Number each carbon in the parent chain. Choose the smallest number. Step 3. Name each alkyl group substituent. Step 4. If the same alkyl group occurs more than once as a branch of the parent structure, use a prefix, D, 3, tetra, and so on, before its name to indicate how many times it appears. Step 5. When different alkyl groups are attached to the same parent structure, place their names in alphabetical order. Step 6. Write the entire name using hyphens to separate numbers from words and commas to separate numbers.
Here are some examples of naming alkanes. First we will have to observe where identify each of the points. Then we will identify the longest branch and will make the numbers. named after the mentioned elements. And finally, we named first start with mentioning that the excess number of boxes are following its name. This is done with each of the remind and finally the number of elements of the main branch sets. This is more examples of this case.
Drawing structural formulas for alkanes. First step, draw the basic structure for carbon in a line. Second step, number the carbons. And third step, place the substitute in the carbon it corresponds. It's very easy. These are the steps to drawing structural formulas for alkane. We have some examples of how to draw structural formulas for alkanes. So the first one we have is 2,2,4-trimethylpentane. So we have in here pentane. So we must put the number of carbon, that in this case is 5. So we put the carbons in a line, and then we have 2,2,4-trimethyl. So in the carbons 2 we have 2 methyls, and in the carbon 4 we have other methyl. We have more examples. 2,3-dimethylhexane. First, we put attention to the basic structure, that is hexane. So we must have 6 carbons in a line. Here we have the 6 carbons, and then in the carbons 2 and 3 we must put a methyl. Here we begin from left to right, and we have in the carbon 2 a methyl, and in the carbon and in the other place other methyl, and we put the other hydrogens to to fill the 4 bonds that a carbon must have to be stable. We have other example, 3-methyl-2-methylpentane. So we have 5 carbons, and then we have in the carbon 3 an ethyl, that is here, and the 2-methyl. We have in the carbon 2 a methyl. The next topic, alkenes. Alkenes are hydrocarbons with at least one double bond. The general formula is this: CnH2n. The UPAC rules to name alkenes. The parent chain must include the double bond. The numbers start from the ending closer to the 2 bond and indicate the location of the double bond. Change the ending "-ane" for "-ine". We have one formula. We have 1, 2, 3, 4, 5, 6, 7 carbons and 2 substituents that are the same, methyl. So we must put attention in which number of carbons are the methyls, the substituents. And then we see the smallest number in which the double bond is, that in this case is 2. Well, the name of this compound is 4,6-dimethyl-2-heptane. For 6, the places in which the methyl is, and 2, because is the smallest number in which the double bond is, and 18 because it has 7 carbons in the longest chain, and in because it's an alkene with the because of the double bond. We have more examples. For example, 3-methylbutene. We have the 4 carbons, the 3-methyl, the 3 in the carbon 3, and the methyl. And the butene because has 4 carbons, and in this situation we don't need to put the number 1 because it's the smallest number in the double bond, so we just put methylbutene. We have other example. Here we have 5 carbons in the longest chain and 1 substituent. The name of this compound is 4-methyl-2-pentene. How to draw structural formulas for alkenes? Draw the basic structure of carbons in a line, number the carbons, and place the substituent in the carbon it corresponds. How to draw structural formulas for alkenes? Draw the basic structure for carbons in a line, number the carbons, and place the substituent in the carbon it corresponds. Examples. First one, we have butene. We have but, that means 4 carbons, and in that has double bond. And we fill the carbons with the hydrogens they need. Other example, 2-methyl-1-butene. We have, first we must write the line of 4 carbons, then we have the 1 because it's the place in which we have the double bond, and in the carbon 2 we have a methyl. 2-ethyl-butene. We have the carbons and then the ethyl. We have one example. It has 5 carbons in the line, and between the carbon 1 and 2 we have the triple bond, and we have one substituent, that is ethyl. So the name of this carbon is 2-methyl-2-ethyl.
Hydrocarbon derivatives. The hydrocarbons are the simplest organic compounds. Contain only carbon and hydrogen, which may be straight chain, branched or cyclic molecules. Carbon tends to form four bonds in a tetrahedral geometry. Hydrocarbons derivatives are formed when there is substitution of a functional group in one or more of these positions. Can form an almost unlimited number of carbon compounds by addition of a functional group to a hydrocarbon.
Functional groups. This table shows functional groups like hydroxide, ether, amino, and others. The compound type is alcohol, and the general formula is ROH. These symbols represent carbon chains or rings bound to the functional group. Some examples of alcohol are methanol and ethanol. The functional group ether, its compound is type ether. The general formula is ROR. Some examples are propyl ether and ethyl methyl ether. Amino is the functional group. The compound type is amine. The general formula is RNH2, and some examples are ethylamine and 1,3-propane-diamine. If you can see the OH or the O or NH2, these are the functional group in the general formula. Carbonyl. The compound type is aldehyde or ketone. The general formula of aldehyde is RCHO, and some examples are benzaldehyde and cinnamaldehyde. The another compound type is ketone. The general formula is RCOR. Examples are 2-propanone and 2-butane. The functional group carboxyl. The compound type is carboxylic acid. The general formula is RCOOH, and some examples are ethanoic acid and methanoic acid. And another functional group is ester. The compound type is ester, and the general formula is RCOOR. And some examples are propylethanoate and benzyl acetate.